A simple pendulum and a mass spring system both have the same time period t at the surface of the Earth. If taken to another planet, where the acceleration due to gravity is twice that on Earth, which line A to D in the table gives the correct new time periods? So let's start with the equations that we are going to be using here. So the time period for a simple pendulum, that's equal to 2 pi root L over G, and the time period for a mass spring system, that is 2 pi root M over K. So let's start with the mass spring system. The mass spring system's time period depends on mass and spring constant. Neither of those things are changing when we go from the Earth to the surface of this other planet. The acceleration due to gravity does not affect the mass, does not affect the spring constant, so the time period should be the same. So for the mass spring system, it will still be t. For the pendulum, this equation does depend on the acceleration due to gravity. So we can see from this equation here that time period is proportional to 1 over root g. G gets multiplied by 2. As it says in the question, on the other planet, the acceleration due to gravity is twice that on the Earth. So g gets multiplied by 2. So we replace the g in the proportionality with the factor by which it changes, so twice as big. Change the proportionality symbol into a times. T, the time period, is therefore 1 over root 2 times what it was before, and that corresponds to C or D, so our answer would then be C.